And we are live. Hello, guys. So, welcome back to Excel Island. If this is the first time here, welcome to the channel. If you're an existing subscriber, welcome back. My name is Abatan Sheriffdeen, and I'm a top rated plus freelance data analyst. I'm a remote worker, a freelancer, and I work remotely from my home. And basically, what I do on this channel so far currently is that I am currently live streaming my learning journey using the resources on the Datacamp platform. So I paid for a 1 year subscription on the Datacamp platform, and I'm trying to live stream my learning journey just to uh, make myself accountable and to be consistent, to be that habit of learning 30 minutes, 45 minutes, so 1 hour daily. And I've been able to achieve that consistently learning for the last 47 days. So you can see this 46. Today will be day 47. So I complete a couple of lessons today. And the idea behind this was to show newbie freelancers or newbie data analysts or newbie data analyst enthusiasts that want to get into the data field, the amount of hard work, the amount of consistency, the amount of dedication you need to put into this tech industry before you can start getting results. You get it now. So that is the idea behind it. And also to share and encourage others try to start in tech, to be consistent, and surely you see results. So I'm also a top rated plus freelancer on Upwork, or I've been freelancing on the Upwork platform. I've had major success. My major success so far in freelancing has been on the Upwork platform. So I've used other platforms also like Instagram, Twitter, LinkedIn. I've not really used Fiverr, so I don't know about that. I think my Fiverr account got blocked due to the fact of my nationality or something like that. But I didn't commit any fraud or whatsoever. It just got banned, and I tried to resolve it. It wasn't resolved, so I moved to other platforms. So if you're having issue on one platform, you can always use another platform to start your freelancing career. You get it done. But I've had major success on the Upwork platform so far. I'm a top rated plus on the platform, and I have someone who has been doing that who has coached me to this day, to this journey. He's still my coach. So his name is Benga DB, and that's a course currently called the Freelance Client Magnet course, which teaches you how to become a successful freelancer and run a successful freelancing business on major platforms like Upwork, Fiverr, LinkedIn, and also remote job websites like we work remotely, like all the old remote job websites you can ever think of on the web. So it will also teach you this course by Benga DBE will also teach you how to use your social media and position yourself to use your social media to what? To land gigs, to run a successful freelancing business. People usually use social media for about their personal life. You can use your own social media for whatever you want to use it for. So you can use it to start a successful business, and you don't even need to use Upwork or other platform again. If you position yourself very well using your social media accounts. So the course also teaches how to do that. I'll leave a link to the course under this YouTube description. Do make sure to check it out. Also, you can check out Benka's BE profile on Twitter. He's my coach. He's someone I have high respect for. He's a highly top rated freelance coach. His success cost across thousands of students, not even 1,000 now. He has a lot of students. He has a lot of testimonials to back his claim up. So if you go to Twitter, let me just show you what it looks like. If you go to Twitter and search for Benga DB, sorry about that, you check his pin tweets, you see his profile there with a lot of testimonials. Hold up, this is coming up. So if I go to the search bar here, I type Benga DB is there. And the cool thing about this course is that you can see here, the cool thing is that it gives you access to Benga DB resources for a lifetime. Once you pay for the course, you have access to him. It also gives you access to a community of freelancers who share common goal and share ideas with them and share their experience also, even to newbies that are just as the people are willing to guide you, to share their experience with you, so you become a successful freelancer also. You can check out Benga DB profile on Twitter. That's him. Don't mistake him for anyone else. There's only one being at DB. You can check it out here. You can check his pin tweet. He has over 20K followers. You can check his pin tweets. His pin tweet also, the pin tweet contains a lot of testimonials from students like me, like you, trying to become a successful freelancer also. So check his pin tweet. This was 2020 in review. So he hasn't even started dropping it. He hasn't. He usually drop his testimonials every day, but he compiled last year testimonials in this thread. Probably by the end of this year, we're going to compile this year's testimonials in 2024. So you are going to see that. So you see a lot of inspiration for over 1 minute, short video, 1 minute of screenshots of students enjoying freelancing on Upwork and other platform also. So back to my data camp learning journey. So I've been learning consistently on data camp for the past 46 days. Today is day 47. Or yesterday I didn't live stream. I just took a couple of questions on the review page. I was really exhausted, but I wanted to make sure the streak didn't break. I have to make sure the streak was consistent. So I could take a couple of review sessions where I could have decided to also live stream that, but I just decided just to do that off live stream yesterday. So if you're looking for day 46, you probably not see it, but I didn't do any live stream on day 46. So you didn't miss anything. You get it now. So on the career track here of data camp, I'm doing a data analyst in career, a data analyst in SQL career track. You can see. So I think I'm 55% into the career track. Let's wait for it to load. Wow, I'm almost through with the career track. This is amazing. I didn't even realize I was that close to finishing the career track. And the goal is 100 days. Probably before 100, the 100th day, I'm going to finish this. I'm going to do a lot of analysis, looking for data sets online and building portfolios and case studies using just writing queries alone. No building of dashboard yet, just writing queries, views, and so on. And I will also be sharing that also live and using it as my portfolio for potential projects or jobs. You can see there are tons of character here. So after the data analyst in SQL, my next target is the data analyst in Power BI because I need to prepare for my Power BI certification. I have this, I have to prepare for Power BI, the popular Microsoft certification in Power BI. I have to prepare for it. Where is it? The data analyst in Power BI somewhere here. It is this here. So I'll start live streaming this one also. So make sure to subscribe if you don't want to. If you don't want to miss that, you could just learn it together on live stream, or you can always watch the recording after the live stream. So I'm on this data analyst in SQL career track. I'm almost through with it. I think I'm half the way. Now that's cool. I'm super excited. It just started like a film tweak, and we are halfway through the journey already. That's cool. That's really cool. So the career track contains 11 courses with one project, and the total hours is 39 hours. You get it now. You can see I'm through with like 6 courses. One, two, three, four, five, six out of the 11 courses. So I'm way 50%. So I'm starting this introduction to SQL. Sorry, introduction to statistics in SQL, then exploratory data analysis in SQL, then data-driven decision making in SQL, then understanding data visualization in SQL, then data communication concepts, then the last project, then the statement of accomplishment. Boom. Then we should be through. So let me just continue. But before I continue, there's always some weak areas to review. So let me just review this real quick. This review 2 weak areas. I always like to review this real quick just to refresh my knowledge of past courses I've taken. So it helped me to, that's I kind of like the Datacamp platform. It allows you to review past lessons. There are also assessment that you can practice also based on past knowledge to practice real life. I think I took a couple of assessments this week 2 times. I could take another one later. And if you check, I think if you check the 45 live stream, I took those assessments. You can check it out there. So let's start this. Let's practice this and see. So subqueries, you are working with the countries and player info table. So this is the countries table. It contains the country's name and the country ID and the player info. It contains the country, the player ID, the player name, the battling and the bowling skill, and the country ID field to link to the countries table. So what is the output of this code? You can say this is a query select ID from countries where the name is South Africa. So you are selecting this ID too. It's going to return ID from countries where the name. So we want to link from this place now. It will return the ID of South Africa here, the ID of 2. We now use this in our subquery here, where country ID in 2. We're expecting South Africa, expecting player name, country ID of 2. Let's check it. So this should be our answer here. Cool, super straightforward. So you are working with player info and seasons table from a database about the Indian Premier League. This is the player info. This is the season. The player info contains the player ID, the player name, then the battling hand of the player, and the bowling skill of the player. We also have the season table, which is just the season ID, then the man of the series in that season, the man of the season, or something of sort. So select the code to return this output. So we're only returning an ID, a battling hand of 2, and a bowling skill of 1. So you see where bowling skill is this. So to be select ID, probably ID from where? Select player info.id, the player info dot the ID of the player, the battling hand and battling hand bowling skill from player info and season, where man of the series is equal to. So I think I kind of did this recently using the where clause. Man of the series equal to player info ID and battling hand is equal to 1. This should be the answer. But the bowling skill here is 1. Oh, okay. No, this should be the answer. Where the bowling skill equals to 1. Where man of the series there, where man of the series there is equal to the player info ID. So I see man of the series here, this is one of the series here, is equal to the player info ID here. Okay, they also have matching ID there. That should be the answer. Yeah. So you are using the rows table shown on to the, you are using the rows table shown to filter role ID column in the match rows table. Okay, the rows table here, this is our rows table. Show to filter the role ID here. You are filtering the role ID in the match rows table. So they didn't show us the second table. So we have to be pretty smart here. So select the code to return the output, match ID, player ID, role ID, and team ID. So where okay, you are using the rows table to filter role ID. Okay, on the match role ID. Okay. Select ID in player, where role ID in it's a match rows table. It's a match rows. So this software is wrong. Let's simply ID here, role ID and team ID. But it's simply ID we are saying here. This is saying when name is on the player. When name goes to keeper, when name goes to captain. We are seeing info about player here. The player ID, the role ID, and the team ID of the player. So we are seeing player there, so it's pretty simple there. Oops. Day 47. I'm looking forward to day 50. Let's go back to the dashboard. I think let's practice the last the long introduction to inner joins. Let's review this last part together. Let's go. So you are working with the venues and the cities tables. This is the venues table, cities table. The venues table has the field venue ID, the name field, and the city ID field, which is the primary key here, which is the secondary key here, so which is the foreign key rather. Then the city ID here is the primary key, which connects to the venues table. We have the city name, the country ID. So select the code to return the output. Select the code to return the output name and venue name. Probably name from here. That will be the name from here also. Then the venue name. That's quite funny. Let's see. So the name could will have come from any of the tables, but the venue name is definitely from here. So probably I guess now, since we don't have venue name here, venue name is not here. Probably an alias to us to the name here. Then the name here, the city name. Let's check that out. Select cities.name, venues.name. Select cities.name as city name. No. Venues.name as venue name. No. Select city.name as name. This is the answer. Venues.name as venue name. You can see the alias gave that code away. From city inner join venues on city ID, cities.id, then venues.city.id. That should be the correct answer. What type of relationship? What type of relationship between students and classes? I think I've seen this before. I don't know why the diagram is not showing. I think it's meant to me. The diagram don't show there. Sorry about that. My light source is itching my eye. Okay. So a query has started. A query has been started. A query has been started to join the venues and cities table from a database about the Indian Premier League, a professional cricket league. So complete the code to return the output. Which code is going to return the venue ID, the name, city ID, the ID, name, and country ID. Please definitely select star. That's the select star from venue as V. You should have now joined there. Then the on clause check. Or ETI. Okay, I think I'm good. Shown below is a preview of the matches and match captains, the match captains and the matches tables from a database about the Indian Premier League. Okay, select the code to return the output. So the match captains has the team ID, then the match ID. The match table has the ID, the team ID, and the match winner. So we are returning this code. The output here is the team ID, definitely from here. The team ID, probably from here also. Then the ID, then the match ID. Let's see that. The team ID, probably from March. Then the team ID also from this probably the team ID here is probably from the captain's table. Okay, let's see this one also. Can see okay, I'll use the inner join. The on clause, the inner join to differentiate the results. Let's see. Let's say where team ID is not equal to the team ID here is not equal to the team ID here. That's not possible because inner join is going to give you. You're not supposed to use that in the on clause. Use equals to. Is definitely the answer. That gave it away immediately. So the songs release and listening tables are shown. The release tables contains exactly one release date for each song in the song table. The listening table contains information about the listeners and all the song they have listened to. Which of the following table have one-to-one relationship? Ooh, one-to-one relationship. One-to-one. Can see the song ID here. It's connected to the release here. This is the release table. And this is the song ID table. Then the list. This is the listing table. Let's say don't have one-to-one relationship here. Oh, I feel that song and release. Hmm. Because the listening, a particular listening, someone could have listened to many songs. So I figured out that I be song and release because the song that was in the record will be one, and the release song will be one release song. But I could have one song and release many, one song ID, yeah, song ID, yeah. Oh, this should have given it away because the release table here, the first few there is the song ID, which is the which will be which will be one-to-one relationship should be a primary key there. Exactly. Then the song ID here is definitely the song table. This is definitely the primary key here. That's a silly mistake I made there. That alone should have given it away. I didn't can we improve. I don't know yet. Come on, what's the problem? You're working with the Venice table. Why do I have to go back? This is not fair. Let's do that real quick. Select from Nigerian class. Aha. So back to dashboard. Oops, what's wrong with my connection? My connection is pretty strong. Aha. So let's continue taking the courses. So what I want to do is continue the introduction to statistics, which I already take a peep of. Let's start from the beginning. So each course usually has like 4 chapters. Normally has 4 chapters. So you can see this is chapter one, chapter two, three, and four. So let's start from the beginning of statistics there.
Hi, and welcome. My name is George, and I'll be your host as we discover the core concepts of statistics.
Oh, let me connect to my AirPods.
So, what is statistics? The field of statistics is the practice and study of collecting and analyzing data. Statistics has two main branches. Descriptive or summary statistics are used to describe or summarize our data, while inferential statistics involve using samples to draw conclusions about the population they represent. We will discuss both in more detail, but first, let's look at why statistics is so important. We interact with statistics every day, from sports announcers talking about player statistics to tracking our personal finances. We are all in tune with statistics. Statistics allows us to answer practical questions, such as, what is the average salary in the USA? Or how many customer inquiries is a company likely to receive per week? It also has applications across society. We can use statistics to improve the safety of products, or to help a government understand the needs of a population. Scientific breakthroughs are validated through the use of statistics, including the conclusion that COVID-19 vaccines were 89% effective in preventing severe disease in older adults in the United Kingdom. So far, so good, but statistics does have its limitations. Statistics requires specific, measurable questions, rather than broad, open questions. For example, statistics can tell us if rock music is more popular than jazz, based on total sales, or whether women live longer than men. However, we can't use statistics to find out why relationships exist, such as why people like different types of music, or why women live longer than men. Now we know what statistics can and can't do, let's define the common data types, which is important for determining how we can analyze our data. First, we have numeric or quantitative data. This can be broken into two subtypes. Continuous data is measured on a continuous scale, taking any value, such as stock price. We also have interval or count data. These are measured in whole numbers, such as counting how many cups of coffee people drink per day. A common way of visualizing the relationship between numeric data is to use a scatter plot. Here, we have visualized the number of thefts in London, England, on the y-axis against the number of vehicle offences on the x-axis, where each dot represents a London borough and the amount of crime occurring determines the position. We see in London, England, on the y-axis. Way of visualizing the relationship between numeric data is to use a scatter plot. Here, we have visualized the number of thefts in London, England, on the y-axis against the number of vehicle offences on the x-axis, where each dot represents a London borough and the amount of crime occurring determines the position. We see one borough has many more thefts than the rest, around 40,000 in total, but can't identify which borough this is. Another data type is categorical or qualitative data. There are two subtypes. First is nominal data, which describes unordered categories such as eye color. The second categorical data type is ordinal data, where the categories are ordered. For example, a survey may ask people's opinion on whether basketball is the best sport, with answers ranging from strongly disagree to strongly agree. We can visualize the relationship between categorical and numeric data by grouping the values, then performing some kind of aggregation. We can group our crimes data by London Borough, which is nominal data, and display the number of thefts, which is interval data, for each borough. This is a great way to compare different categories. We can now see that Westminster is the borough with a high volume of theft. Now we've looked at data types and common ways to visualize them, let's return to the two main branches of statistics. Descriptive, or summary statistics, are used to describe or summarize data. Using our data on London crime as an example, we can describe that thefts in Westminster account for around 36% of all thefts in the 5 boroughs shown here. By contrast, inferential statistics is the process of using a sample to draw conclusions about a population. For example, we can survey 100 people on whether they purchase clothing after seeing social media advertising, and use this sample to infer what percentage of all people purchase clothing as a result of social media advertising. Now, let's check our understanding of statistics.
Okay. This one says using statistics in the real world. Recall that statistics can help to answer specific, measurable questions. In this exercise, you have been provided with several real-world scenarios and need to select which one can be solved through the application of statistics. So why do people prefer dogs to cats? Why? Is there a why for that? Testing whether a new brand of car is safer than the current model. Testing. This is possible. Why do people prefer dogs to cats? That's not possible. What factors can make one TV show more popular than the other? What factors? What is most winning lottery numbers? This is not possible. You can't know what will happen tomorrow. Yeah? What factors? I'll go for that. Yeah. You can use inferential statistics to check whether a new product improves on the current version. Is common practice in any. That's painful. So it says, so identifying data types. You saw that there are two main types of data, numeric and categorical. So numerical data can be classified as either continuous or count or interval, or continuous count slash interval, and categorical data can be classified as either nominal or ordinal. So the data type determines which approach are suitable when summarizing your data. So you've been provided with several examples to classify as continuous count, nominal, or ordinal. Okay, continuous count, nominal, ordinal. That is continuous is under numeric, count is under numeric, nominal, ordinal is under descriptive. So customer satisfaction, unsatisfied, neutral satisfied. That should be ordinal. So that's like a survey data type. So height in centimeters. Mm, height is continuous, man. You can keep going in height from a baby, and you go up. Race car lap time. The race car will be different. Very look at that is continuous. Income status, low, middle, high. Oh, that's categorical. That's nominal. Number of trees in a field. That is count. Accounting that. Count of t-shirts sold in a store. The count can increase. That is a count. Also, okay. Employment status. That is nominal. That's categorical. Yeah, soccer player position. Uh, soccer player position. Come on. Let me see. Soccer player position. That should be nominal too. But that should be nominal too. I'm missing something somewhere. Let's see. Aha. So ordinal. Oh, this is like income status. Low, medium, low, middle, high. Mm, let's just okay. Employment status. I didn't tell whether it is number, but this category is soccer player position. Okay, midfielder or striker, left back, right back. This is nominal. So I'm guessing this one will be here. Aha, I got it. Okay, so descriptive versus inferential statistics. So we call that there are two main branches of statistics, which is descriptive statistics and inferential statistics. So understanding what type of statistics is required for a given solution is an essential skill in order to draw accurate conclusions. Now you have the opportunity to check your knowledge of how these two branches of statistics are used in practice. You classify each scenario as a task for descriptive or inferential statistics. So after surveying only that thought survey, you know yes survey, you know that is descriptive. That is descriptive. No argument about that. Mm, yeah. Survey. Hold up. Give me data of all projects completed. What percentage were delivered on time? Mm, let's do this also. Give me the scores for the student at your school. What is the average score for all students in that school? Average score for all students in that school. Mm. Average score. Is it describing? Hold on, let me see the last one. Give me data on all projects. What is the average amount spent per customer? So we are summarizing our data, giving data. What is the average number of this is descriptive. Given the test score of the student at a high school, what is the average score? This is descriptive also. So inferential is to collect a sample. Okay. Okay. After surveying 100, how many hours of sleep? Surveying on the can see surveying on the can see it is differential. Given that an output is complete, what percentage were delivered on time? That is what percentage? Let's see this. I know I missed it. I'm missing one. What percentage was completed on time, was delivered on time? So this is also the year. This okay, giving test score for 50 students also. This is the population. So the population of 50 students as one as what is the average score for all students in that class? Uh, Giving a test score out of we are taking part of the population. Uh, so I misplaced it. It says all projects and summarizing all the data. So you can see the all. So one is taking sample, which is the inferential statistic. So that is summarizing all the old data. That is the trick. I found the trick. So you can figure out if the data you're taking part of the data, you're using all the data. So you can know that one is descriptive, one is inferential. So measure of center, which is the mean, probably the mean. Measure of center tendency, measure of the center.
Now let's discuss summary statistics, starting with measures of center. So, why are measures of center useful? We might be asked, what are the average number of sales orders per month at work? Hear about the typical cost of a house, or wonder what the most common hair color is? Terminology like average, most common, and typical value are all examples of how measures of center are expressed in day-to-day life. We will use the crime dataset introduced in the previous video to review measures of center. Each row contains a London borough and the count values for each type of crime over the past 2 years. Here is a preview of the first 5 rows. We can see there were 5,067 burglaries in the London borough of Barnet. Let's explore another way to visualize numeric data. A histogram takes data points and separates them into bins, or ranges of values. Here is a histogram of vehicle offences with 8 bins, each with a separate height corresponding to the number of London boroughs with a vehicle crime count that fits inside the respective bin. The peak, in the middle, shows 9 London boroughs had between 6,000 and 7,300 vehicle crimes in the past 2 years. Histograms are a great way to summarize numeric data, but we can also use descriptive statistics. We could summarize the data by finding the typical amount of vehicle crime in a London borough. To answer this, we need to determine what the typical or center value of the data is. Unfortunately, this can be hard to determine through data visualization such as our histogram. We'll discuss 3 ways to calculate the center: mean, median, and mode. The mean, often called the average, is one of the most common ways of describing the center of the data. We calculate the mean by adding up all values and divide by the number of values. For example, to calculate the mean number of burglaries per London borough, we add up all values and divide by the number of boroughs, which is 32. This gives us approximately 3,463 burglaries. Here, we can see the mean value for each type of crime and overall, with theft having the largest mean. Another measure of center is the median. This is the middle value for our data. Therefore, if we sort our data from smallest to largest, as shown here for burglaries per London borough, 50% of values should be lower than the median and 50% should be higher. We have an even number of values as there are 32 boroughs, so we instead take the 2 values closest to the middle. We add the 2 values, then divide by 2. The result is 3,416.5, slightly lower than the mean. The third measure of center is the mode, or most frequent value. If we count occurrences of each crime across all London boroughs, we can see the most frequent value is theft. If we are looking for the expected value of categorical data, then the mode is generally the most suitable measure, since categories may not have an inherent numerical representation. Which measure to use depends on the situation. Take this histogram of vehicle offences, for example. The shape of the plot is fairly symmetrical, with a count peaking in the middle and getting lower towards each side. When data is symmetrical, the mean and median both work well. Notice they overlap on the plot? Comparing this to robberies, the data is not symmetrical, piling up on the left and tailing off with one borough having a high overlap on the plot, the mean and towards each side. With use depends on the situation. Take this histogram of vehicle offences, for example. The shape of the plot is fairly symmetrical, with a count peaking in the middle and getting lower towards each side. When data is symmetrical, the mean and median both work well. Notice they overlap on the plot? Comparing this to robberies, the data is not symmetrical, piling up on the left and tailing off with one borough having a high number of robberies. When one value is substantially different to others, we call this an outlier. This outlier pulls the mean towards it, while the median, this outlier, piling up on the left and tailing off with one borough having a high number of robberies. When one value is substantially different to others, we call this an outlier. This outlier pulls the mean towards it, while the median is less affected. This is because the mean calculation involves adding up all values, so larger values affect the result, whereas the median just looks at the middle value. Therefore, when data is not symmetrical, it is best to use the median to describe the data's typical value. Now, let's center ourselves with symmetry is not symmetrical. Therefore, when data
it is best to use the median to describe the data's typical value. To use the median, which is the middle number. Okay, that's probably the mean.
data is not symmetrical, it is best to use the median to describe the data's typical value. Now, let's center ourselves with some exercises.
Okay, let's do some exercises. So, typical number of robberies per London borough. So, in the video, you saw that the mean and median can both provide information about the typical value of a variable. Here are three definitions representing the mode. Here are three definitions representing the mode, the median, and the mean, along with their respective values for robberies in the London crime dataset. Add up all values and divide by the number of observations. The London borough where robbery occurs most frequently, that is the mode. Sort all the data and take the middle value. This is the median. This is definitely the mean. Looking at the table, what are the values of the mean and median? The mean, the answer, that's the mean and the median. Okay, choosing a measure. So selecting the correct measure of center is essential when describing a typical value of the data being observed. An app has been displayed which shows a histogram of robberies in London. You can use the app to change which type of crime is displayed and whether to include a dotted line for the mean or median. Your task is to decide which type of crime has a symmetrical histogram and can be accurately described by both the mean and the median. Okay, so the type of crime. This is the type of crime that is not symmetrical. Let's see. That is not symmetrical. Here is 2000, 4000, 6000. Hmm. Let's see the robbery. This is not significant at all. It's probably it's between the drug offense and the public order defense. So we'll go for the mean. That's with the drug offense and the mean. Oh, I feel that. With the mean is more accurate. So public order offense. Uh, Most of the values. See the median here. Probably the median number. Let's see the robbery. We have a missing. Something is missing there. Something is missing here, so it's not that. Are we going to say this one? Because this is more distributed. This is more pretty distributed. Let's go for the median. The high count of London Borough with around 2000 less. Both the mean and the median. So if you are using median or use mean there, it's also accepting the median. Uh, Public officers. Oh, let's see. Let's calm down and see now. So we want to take so let me just so my task is to decide which type of crime has a symmetrical histogram and can be accurately described by both the mean and median. But I can only select one single measure of center here. Um, when I look at the robbery here, the mean is not in the center at all. But if you use the median, the mean is not in the center. But the line, if you look at this one, this is pretty close. This is like 3000 in the middle, 4000, 5000, 6000. If you choose the median there, so it's the median that is more accurate here. So exactly, the median is more accurate here. But when you look at the mean will be accepted also. Look at the robbery. The mean is way wide. The median rather is way wide than the mean. Look at the median here. It's even the mean here. Look at the median shifted here. The mean shifting here. Then the drug offense. This is the mean. And look at the median. Almost very close though. The median is different. Look at the dotted line. And the median is different. Moving. Let's look at the Asson. Look at the median. Let's look at the mean. Oh, it's almost the same. This is not funny. Yeah? Public office is the mean. Let's look at the median. Almost the same thing. Let me see. Then the value should be the same. Exactly. So none of the values are the same. So if the mean and the median both accurately describe the data, the value should be the same. The mean will be the same with the median. Exactly. So none of them is the same. So none of the crimes. Oh, man. I didn't expect that there was none of the crimes there in the answer. I didn't see the last option. Imagine. That was what I didn't pay attention to that. I just after getting the mean. Probably because I didn't understand what the mean and the median means in the first place. That was the issue then. None of the crime was correct there. I just wasted a couple of times there. But I actually learned something because the mean is the same as the median. So none of the mean and the median were shifting. So London Borough with the most frequent crimes. So the median and the mean are great for summarizing numeric data. But if you want to understand the typical value of a categorical variable, then these measures can be applied. Then you need the most there. So an app containing the count of values of okay, an app containing the count of various crimes for each London borough has been provided. You can use the arrows next to the column names to sort the data from smallest to largest and vice versa. So using this, your task is to find which London borough are the mode for vehicle offense. Okay, which London borough are the mode? Okay, are the mode for vehicle offense and burglary. Okay, uh, you can use the arrows. Where is the arrow? So the arrows there. Uh, to store the data from smallest to largest and vice versa. Okay, okay, smallest to largest, is largest to smallest, smallest to largest. You say define which London borough has the mode for vehicle, some after the vehicle offense, has the most mode. This is not fair. How do I look through this now? And burglary, some after the vehicle offense and burglary. So this is actually mixing it too much. The mode is the highest occurring number. So I'm saying 11292 here, which is the highest there. What about for burglary? For burglary, let's see. I'm saying Enfield for vehicle offense. But for the burglary, let's take a look. I'm seeing tower arms 415183. Okay, 1432. I'm seeing Enfield for vehicle offense and tower. That is the last one again. Oh, that was pretty straightforward. Okay, I think we're halfway through this chapter. Oh, let's finish this chapter. I'll just finish this chapter one today. Yeah, let's finish this quite measure of spread.
Now let's discuss another category of summary statistics: measures of spread. Spread describes how far apart data points are. Here is a histogram of vehicle crimes across London boroughs. Comparing this to a histogram of burglaries, we can see the spread is much narrower. Measures of spread. Spread describes how far apart data points are. Here is a histogram of vehicle crimes across London boroughs. Comparing this to a histogram of burglaries, we can see the spread is much narrower. Spread is important because it tells us how much variety may occur in our data. For example, if t-shirts typically cost $30 but can be anywhere from $10 to $200, then how likely is it we will find one equal to $30? Does this change if t-shirt costs are between $20 and $50? So what measures of spread exist? The first is the range, which is the difference between the maximum and minimum values. For example, here are the London boroughs with the largest and smallest number of burglaries. The range would be 5,183 minus 1,432, highlighting that Kingston upon Thames had 3,751 fewer burglaries than Tower Hamlets in the last 2 years. Another measure is variance, which calculates the 81 fewer burglaries in 83 minus 1,432, highlighting that Kingston upon Thames had 3,751 fewer burglaries than Tower Hamlets in the last 2 years. Another measure is variance, which calculates in the last had 3,751 fewer burglaries than Tower Hamlets in the last 2 years. Another measure is variance, which calculates the average distance from each data point to the mean. This plot shows the distribution of crimes per London borough, with the mean displayed as a vertical line. We can see one borough is much further away from the mean. To calculate the variance, we first measure the distance from each data point to the mean value. For example, the total number of crimes in the London Borough of Westminster is 94,923, and the mean number of crimes across all boroughs is 47,672. To calculate the distance, we subtract the mean from the number of crimes in Westminster, 94,923 minus 47,672. We repeat this by calculating the distances for each borough and adding them up. Unfortunately, if we add up all the distances, then negative values will cancel out positives, so in this case we end up with an overall distance of 0. To avoid this, we square each distance and add them together. This gives us a total of over 7 billion. As the data represents all crime in London, the variance is the sum of the squared distances divided by the number of boroughs, which is 32. It's important to note that the variance is in squared units. In this case, the count of total crime squared. It's difficult to understand the count of total crime squared. Therefore, we can convert it to units of our data by taking the square root of the variance, a measure known as the standard deviation. This gives us a value of 15,319. Generally, the closer the standard deviation is to 0, the more closely clustered the data is around the mean. Here, we can see how dispersed the data is by showing a distance of 1 and 2 standard deviations away from the mean. We can also measure spread using quartiles. which are a way of splitting the data into 4 equal parts. Here, we see the minimum value for various crimes in London and the 4 quartiles: 25%, 50%, 75%, and 100%. For each quartile, the value represents the percentage of values that are less than or equal to that number. We can see that 75% of London boroughs had less than 4,392 burglaries in the last 2 years. Note that the second quartile is the middle value, so it is equal to the median. We can visualize quartiles using a box plot. The left edge of the box is the first quartile, the middle line is the median, and the right edge of the box is the third quartile. Extreme values are shown beyond the horizontal lines, such as the dot above 4,000. Another measure of spread is the interquartile range, or IQR. It is the distance between the first and third quartiles. For robberies in London, the IQR is around 1,080, meaning the middle 50% of boroughs still differ by 1,080 robberies. The benefit of the IQR is that it is less affected by extreme values than other measures of spread, such as the standard deviation. Now, let's practice measuring spread.
That's like elementary mathematics, interquartile range, quartiles. Let's see. So defining measure of speed. So in the video, you learned about several measures of spread, the range, the variance, and the standard deviation. So how do you calculate each measure, and what can then tell us about the data? So three buckets have been included, one for each measure. You will need to match the definition and use for each measure to the appropriate bucket, the range, variance, and deviation. So this measure uses the variable unit to show the distribution of data points from the mean. Distribution of data points from the mean. That is variance. If you have variance of standard deviation. So this measure uses squared units of a variable, mainly used as an intermediate step when calculating standard deviation. When calculating standard deviation, so to calculate this measure, square the distance of each data point from the mean and add up the result. That is the variance. That is square. So the measure is calculated by finding the difference between the minimum and maximum value of the variable. So this measure shows how spread out the data is between the smallest and the longest value. That's definitely the range. And this measure is found by taking the square root of the sum of square distance. This is the standard deviation. So then the measure uses variable units to show the distribution of data points from the mean. So this measure uses squared unit of a variable. That's quite straightforward though. Squared unit of a variable. So that means the range is quite easy to know. The variance is this measure uses squared unit of a variable, so it is generally used as an intermediate step when calculating the standard deviation. Calculate the measure square distance. That's quite straightforward though. Interesting. So let's finish this section. Oops. We're almost through with chapter 1. Okay. So data visualization can be useful in highlighting measures of spread, such as interquartile range. So below is a box plot, or in Excel it's called box and whisker chart. So below is the box plot displaying the number of crimes across all London boroughs in February 2021, grouped by the type of crime. The task is to use the plot to determine which type of crime had the largest interquartile range for this month. Oh, that's not fair. I have to with a quarter range. When you look at it rather, you can say probably the theft or the vehicle offense. I mean, both of them will be there. But let's see. How do you know that? With a quarter range is calculating the first quarter minus the third quarter minus the fourth quarter. So we are subtracting the first quarter from the third quarter. So the first quarter is usually here, then the mean here, then third quarter here. The distance from here to here is the first quarter, from here to here is the mean, from here to here is the third quarter, from here to here is the fourth quarter. We want to minus the third quarter from the first quarter. What should I go for? I have to look at the number. So I have to look at the number here. This is so I'm to subtract this vehicle offense. Let's subtract the third quarter, which is the mean here, which is like 250 here. Is it not like 250? This is less like 2 something. 2 something here. It's like 300 here. It's 300 minus the first quarter. This first quarter here. 300 minus. It's like 0. This is like 20 or 30. Yeah. This is where the first quarter point is. So I'm saying 300 minus the first quarter. That is like 2 something. This is like 250. I'm going for the theft. Let's keep it short. The theft. Aha! I need for the theft. The theft has the highest theta quarter index. Even looking at the diagram, you could be able to fish that out. So which crime has the larger standard deviation? Has the larger standard deviation? Is that public? I mean, you need to know the distance. For the final exercise of this chapter, it's time to see how you interpret spread using standard deviation. So two histograms are displayed, one for public order offense and the other for miscellaneous crime against society. Your task is to choose which type of crime has a larger standard deviation. Mm, it's not possible though, because I can't see the distribution of offense. The mean, we have to know the mean. I think we can the mean and the median. If you look at the middle here, the mean here is 500, 600, 700. The mean here is not correct. So, uh, let's go for the first answer because it's possible. So I'm going for the mean here. I'm going for public offense. Aha, I think it's definitely public offense because looking at the mean has to probably be in the center or something like that. So I just use the mean to get the answer there. So look at the mean here. There's an even spread in the mean. So we know this chapter though. So let's go like more over in chapter 2. So if we move to chapter 2, probability and distribution. And we'll have to stop here. No rushing, don't want to rush all your course and overwhelm yourself. Let's go back to the dashboard. So we are 25% into this, so we achieved our day 47 learning streak. So that will be the end of the live stream for today. All right, so thank you for staying to the end of the live stream. So I would love to stop here and we'll continue from here on day 48. So if you found this video useful, if you find the live stream useful, just smash the subscribe button, give this video a thumbs up, and put on the notification bell to be the first to know anytime I go live. So you can join me and learn together. Also, don't forget to check out the DB's course using the link in the YouTube description. Purchase FCM, and I'll see you tomorrow.